All right, let's just dive right in. For pretty much a century now, there's been this deep, really unsettling puzzle sitting right at the heart of modern physics, and it challenges, well, everything we think we know about reality itself.
And it all boils down to this super famous phrase from Albert Einstein: spooky action at a distance. What he was talking about was quantum entanglement. This bizarre thing where two particles can be linked, so that if you measure one, you instantly affect the other one. And it doesn't matter how far apart they are. Across the room or literally across the galaxy, it happens in an instant.
Now, this whole idea it's completely counterintuitive. I mean, it seems to break the cosmic speed limit, the speed of light, and it suggests that the universe is connected in a way that just doesn't make any sense in our everyday lives. And you better believe physicists have been arguing about it ever since.
So we're going to unpack this whole spooky paradox, but we're going to come at it from a completely different and maybe even more mind-bending angle.
What if the problem isn't the spooky action? What if the real spookiness, the thing we should have been questioning all along, is our most basic assumption, that the universe is made of separate, distinct things in the first place? You see, some physicists are now arguing that for 100 years, we've been so focused on the action at a distance part that we've been asking the wrong question entirely. The whole debate, they say, needs to be reframed.
And this brings us to a new idea: a spooky distinction. The thinking here is that the paradox isn't out there in nature, it's actually in our theories, that quantum mechanics itself might be artificially carving up a unified reality into these separate little pieces, and that act of separation is what creates the illusion of a spooky connection between them.
And this leads us to a pretty radical but kind of beautiful new concept that might just dissolve the paradox entirely. It suggests that maybe, just maybe, we live in a world without seams. So the standard way of thinking about all this is called non-locality. It pretty much accepts that, yep, separate objects exist, and yep, they influence each other in this bizarre, faster-than-light way. It basically just throws its hands up and accepts the spookiness. But the alternative, non-separability, suggests a totally different path. This idea proposes that there are no fundamentally separate objects to begin with. The particles we're measuring, they're just temporary projections, kind of like ripples on a single unified ocean. The difference here is profound. Non-locality says, okay, we've got separate objects with a mysterious interaction. But with non-separability, the whole mystery just dissolves. I mean, if there are no separate parts, there is no distance for an action to travel across. The connection was always there, because it's all one thing. So the crucial point, the real takeaway here, is this powerful statement. Our very human intuition to slice and dice reality into different objects is, at the most fundamental level, just not right. It's a useful illusion for getting through the day, but it's not how the universe actually is. Okay, I know this is a pretty abstract idea. It's a lot to wrap your head around. So let's use a simple model to help visualize it. The idea of two levels of reality. Think about that classic saying, the map is not the territory. A map of a city is incredibly useful for getting around, right? But it isn't the city itself. It's a simplified representation. Well, that's the key idea here. Our scientific theories are the maps, not the actual territory of reality. So this gives us two levels. Level 1 is the territory. That's the real, fundamental, unified reality. This is where nature truly lives, seamless and whole. And then there's level 2. That's our map. In this case, that's quantum mechanics. And it's an incredibly powerful and accurate map, but it's still just a projection of that deeper level 1 reality. And here's the punchline. All the quantum weirdness, all the spookiness, it all pops up because we keep mistaking the features of our map, level 2, for the features of reality itself. We're seeing a strange symbol on the map and assuming there's something truly strange out there in the territory. Now, this isn't just some neat philosophical trick to think about. It's actually a proposal for a concrete new direction in physics research. The goal is nothing less than discovering the mathematics of level 1. And the approach is kind of two-pronged. On the large scale, you have researchers looking for the math of level 1 hidden inside Einstein's theory of general relativity. And on the small scale, the goal is to develop a totally new kind of geometric math that can explain quantum properties from the ground up. A key part of this actually involves rethinking Einstein's equations. So instead of seeing the universe as geometry being warped by particles and energy, this approach suggests that what we call dark matter might not be particles at all,
but huge, large-scale waves in the very fabric of a unified geometry. The ultimate ambition here is just incredible. It's to show that properties we think of as totally fundamental, things like mass, charge, and even the weird quantum spin of particles, aren't fundamental at all. They might just be features that emerge naturally from the shape of this deeper geometric reality. And this brings us to a beautiful analogy that really just sums it all up. For a century, we've been like people in Plato's cave, staring at shadows on the wall. We've become absolutely obsessed with the strange behavior of those shadows, our quantum paradoxes, instead of turning around to understand the single, unified object that's casting them. So I'll leave you with this thought to chew on. Maybe the most profound question we can ask isn't about the individual parts of the universe and how they work. Maybe the real question, the one that could unlock everything, is simply this: how does it all hold together as one?